Hello guys, welcome back. This is the third lecture of the series Electrical for GATE and IES. In this lecture we are going to discuss important numericals related to electrical circuits. If you haven't watched first and second video, you can watch those. The link is given in the description below. This is all about me. I have done BTech from BIT Misra and MTech and PhD from IIT and IIT Kharagpur, and I have cleared GATE and Indian Engineering Services exams. So in this lecture we are going to solve some numericals which are based on current and voltage waveforms. These numericals are important with respect to IES and GATE exams. First of all, for solving these numericals, we need to learn about equation of a line. The equation of a line is given by y is equal to mx plus c. Y is the y-axis and x is the point on the x-axis. M is the slope and c is a constant. The slope is, if we know 2 points on the line, then the slope of the line will be given by m is equal to y2 minus y1 divided by x2 minus x1, where y1 x1 and y2 x2 are the 2 points on the line. Now this equation is further given by y minus y1 is equal to m into x minus x1. This is the first numerical which we are going to solve today. A pulse of plus 10 volt in magnitude and 2 seconds in duration is applied to the terminals of a lossless inductor of 1 Henry. We have to find the current through the inductor. First we draw the given voltage waveform. It is a pulse of 2 second duration and 10 volt amplitude, so it will be like this, and the inductance is given to be 1.0. Now we have to the current. We will be using the formula V is equal to L di by dt, so I will be integral of 1 by L V dt. L is constant, so it will be out of the integral, so it will be 1 by L integral V dt. Now the voltage waveform that is given by for 0 to 2 seconds it is 10 volts, and beyond 2 seconds it is 0, and beyond 0 to 2 seconds it is 0. So integral will be only from 0 to 2 10 dt, so it will be 10 t 0 to 2, so that will be 10 into 2, that is 20 ampere for 2 seconds. The current waveform is 10 into t, so the line will be increasing from 0 to 20 for 2 seconds, and beyond 2 seconds it will be 20 ampere, and before 0 seconds it will be 0. I hope this numerical is clear to you. If you have any doubts, please ask in the comments. This is the next numerical. Voltage current waveforms are shown. We have to identify the circuit element and find its value. From the voltage and current waveforms we can write the equation. So voltage waveform is like V is equal to 2 volts for the time 0 to 2 seconds, and beyond 2 seconds it is 0. Voltage is 0. And similarly current I is equal to the time t for 0 to 2 seconds, and beyond 2 seconds the current is constant at 2 ampere. Now we will check whether the circuit element is a capacitor or an inductor. First we check for capacitor. For capacitor we know Q is equal to Vc, so I will be equal to C dV by dt. Now voltage is constant 2 volt, so dV by dt will be 0. So current I will be 0. That is false, because current I is either T or 2 ampere, so it is not a capacitor. Now we check for the inductor. For inductor V is equal to L di by dt, so that is now I is equal to T, so for 0 to 2 seconds, so V is equal to L for 0 to 2 seconds and equal to 0 beyond 2 seconds, and that is true. So the circuit element is a inductor and its value is equal to 2. So we have found the circuit element and its value. If you have any doubt related to this numerical, please ask in the comments. Now we move on to the next numerical. In this numerical, current waveform across a resistor is shown. The resistor value is 10 ohm. We have to calculate the power dissipated in the resistor. Now we first write the current waveform equation. I is equal to 3 into t. For each 3 seconds, the current waveform equation is 3t. This is because slope of the line is 3. That will come from 9 by 3. That will be 3. Now power dissipated will be I square R. So that will be equal to R integral I square dt. So I is equal to 3t. So on solving this, we will get power dissipated equal to 270 watt for each 3 seconds. This is a simple numerical. If you have any doubt regarding this, please ask in the comments. Again, a similar question is asked. The voltage and current waveforms are shown. We have to find the value of the nature of element and its value. So we first write the voltage and current waveforms. The voltage waveform will be equal to 10t and that will be equal to 10 at I is equal to 2. Now we check whether it is a capacitor. For capacitor we know I is equal to C dV by dt, that is equal to 10C, and for inductor V is equal to L di by dt, so that will be equal to 10T by L. Sorry, di by dt will be equal to 10T by L because V is equal to 10T. On integrating I, we get I is equal to 10T square by 2L. So I will be equal to 5t square by L. Now at t is equal to 1 and 2 seconds, we get at t is equal to 1 seconds, we have I is equal to 2 amperes. So we will get the value of L equal to 2.5. We can see I is equal to 5t square by L satisfies the current equation at both the time values t equal to 1 and t equal to 2. So the given circuit element is an inductor and its value is 2.5. This numerical is also solved. If you have any doubts, please ask in the comments. Now we move on to the last numerical of this lecture. In this numerical, a triangular wave voltage is applied across a 0.5 microfarad pure capacitor at time t is equal to 0. The waveform is shown. So this is the waveform and we have to find the current wave. So first we will write the equation for current wave. For a capacitor we know that Q is equal to Vc. So I will be equal to dq by dt, and differentiating Q is equal to Vc with respect to time, we get dq by dt is equal to I, and that is equal to V dc by dt plus C dV by dt. Now capacitance is constant, so dc by dt will be equal to 0 and we will get I is equal to C dV by dt. Now we write the equation of voltage waveform, that is equal to the slope of this voltage waveform is equal to 20 by 2, that is 10. In fact it will be minus 10, minus 20 by 2, so it will be minus 10. Now we write the equation of a line with one point known on the line. So we take the point 10 0, means at x-axis equal to 0, y-axis is 10. So the equation of the line will be y minus 10 is equal to minus 10 into x minus 0. Minus 10 is the slope. So y is equal to minus 10x plus 10. Here y-axis is voltage and x-axis is time. So v is equal to minus 10t plus 10. Now Now substituting this value, this equation of voltage waveform in I is equal to C dV by dt, C is equal to 1 by 2, so I is equal to 1 by 2 dV by dt. Now dV by dt, that will be equal to minus 10, because V is equal to minus 10t plus 10, so its differentiation with respect to time will be minus 10. Therefore I will be equal to 1 by 2 into minus 10, which is equal to minus 5. Now this is for time 0 to 2 seconds. From the voltage waveform we can see that from time 2 to 4 seconds the current waveform will be 5. This can be easily get similarly, and you can analyze it and write it directly. So we have solved the last numerical of this problem. If you have any doubt regarding it, please ask in the doubts. So thank you for watching the video. If you like it, please share it with the relevant audience so that more people can be benefited from it. Thank you.